Guys, today we're doing the 2005 AP Physics B free response question, Form B. It says, the figure shown above shows 2 point charges, each of charge negative 2q fixed on the y-axis at y equals positive a and y equals negative a. A third point charge of negative q is placed on the x-axis at x equals 2a. Express all algebraic answers in terms of q, a, and fundamental constants. So part A says, derive an expression for the magnitude of the net force on the charge q, negative q, due to the other 2 charges, and state its direction. So, part A, I guess we'll put over here. The 2 forces added is the force of negative q. Also, because the y components of negative 2q and negative 2q repel, y components of negative 2q repel, they cancel out. Net force magnitude is the sum, is equal to the sum of the x component magnitudes. So you're going to have fx equals 2kq times 2q over r squared cos theta. And cos theta will be equal to 2a over radical 5a, which is equal to 2 for radical 5. So when you plug that into there, you get fx equals 8kq squared over 5 radical 5a squared in the positive x direction, because it'll go that way. So that was part A. Part B now says, derive an expression for the magnitude of the net electric field at the origin due to all 3 charges, and state its direction. So B, we'll put that over here. You'll have the negative 2 charges cancel again, and your magnitude, negative 2q charges, cancel, and the magnitude of the electric field will come from the negative q charge. You're going to end up with an answer of E equals kq over 4a squared in the positive x direction. Once again, because that way. So part C now says, derive an expression for the electrical potential at the origin due to all 3 charges. So this one, you're going to do down here. It's a long one. C, you're going to have V equals K sigma Q1 over R1. So you're going to have V equals K negative 2q over a plus another one of those for those two charges, plus the other one, k of negative q over 2a this time. Then you're going to end up with v equals negative 4 kq over a minus kq over 2a, which is equal to negative 8 kq over 2a minus kq over 2a. And your final answer will be negative 9 kq over 2a. So now, part D. On the axes below, sketch a graph of the force on the negative q charge caused by the other two charges as it is moved along the x-axis from a large positive position to a large negative position. Let the force be positive when it acts to the right and negative when it acts to the right, and negative when it acts to the left. You're going to start here, go down, go straight up, and it'll be you'll have an asymptote at your x-axis because the charge never disappears. It'll just get closer and closer to 0. And you have your max force here because you won't have anything higher than that. You're only going to have one max too and one minimum. And that's it for this video.